An aggregate function takes all values of some expression, such as a column name, from all the rows in a group and does something with them. Takes the max or the sum. Now, by default, all rows that are used to compute the final table, meaning the ones that passed the filter in the where clause, are all in the same group, one big group. And so the result, when you apply an aggregate function, only has one row. But it's actually possible to define a select statement with multiple groups. So rows in a table can be grouped together, and aggregation is actually performed on each group individually. So here's another form of a select statement. It says select, still has column descriptions. Remember, these expressions can contain aggregate functions from some table where I group by some expression, and I keep the groups having some property. Group by and having are both new. Let's focus on group by. The number of groups is the number of unique values of some expression which you place here. So here's our animals table. And here's a select statement that says select the number of legs and the maximum weight from animals group by legs. What group by does is it partitions all of the rows from the animals table by the unique values of what value is in the legs column. So we have 4 here, we have 2 here. Those form two different groups. The legs equals 4 group and the legs equals 2 group. Each of those is going to result in a different row in the table that we get by selecting legs, max weight. Now legs here, because it matches the group by, will give us the value of the legs for that group. It's really giving us the legs value for some arbitrary row, but they're all the same, so we get 4. And then it computes the maximal weight by maximizing over all the rows in this group. So the maximum weight for a 4-legged animal is 20, and the maximum weight for a 2-legged animal is 12,000. This notion of grouping together rows and then aggregating those groups is actually quite powerful. So let's look at some more examples. I can select the number of legs in each group from animals where I group by the number of legs. That will give me 4 and 2, which are the unique values of the expression legs. Now I can also compute the count of the number of rows that have those many legs. Okay, so there are 3 different animals with 2 legs and 3 different animals with 4 legs. And like I said, I could also compute the maximum weight in each of those categories. 12,000 pounds for a 2-legged beast, 20 pounds for a 4-legged beast. It is possible to group by more than one column at a time. So I could get the legs and the weight from animals, where I group by both the legs and the weight. So here's all the unique combinations of a value for legs and a value for weight. Notice there are only 5, whereas we had 6 rows in the beginning, because ferret and cat have both the same attributes. I can actually group by any expression I want. So I could get the maximum kind along with the value of dividing weight by legs from animals, where I group by the value that I get dividing weight by legs. Now SQL performs integer division when it divides 2 integers by default. So what I'm dividing is 20 by 4 to get 5, or 10 by 4 to get 2, or 6 by 2 to get 3, or 10 by 2 to get 5. And I see that there's various values that I get, and here it's picking the alphabetically last kind of an animal for each ratio of weight to legs that I can possibly get within the animals table. So here we've seen grouping by a particular column value, multiple column values, or an arbitrary expression. Now, sometimes when you group rows together, you want to keep some of those groups around and get rid of others. A having clause filters the set of groups that we keep for aggregation. Now, we also have a where clause to filter individual rows, but a having clause can even include aggregation itself. So here is a select statement where we've said we want to keep the result of weight divided by legs and the count of the number of rows that have that weight to leg ratio from the animals table, where I group by this arbitrary expression, weight divided by legs, but I only keep the groups that have a count greater than 1. So how does this work? Well, it computes weight divided by legs for each row. Weight divided by legs can be 5 or 2 or 3 or 5 or 6,000. We group by this value. So the unique values are 5 or 2 or 3 or 6,000. And then we apply the having clause to filter any group that doesn't have a true value for this expression. So the count has to be 1, which means that we need weight divided by legs to be 5, which has a count of 2, or weight divided by legs is 2, which has a count of 2. But both of these groups are discarded.